I am basing this discussion on my observations on how much you know about factoring quadratic trinomials. Before I even do anything, I want to make sure that you understand when you multiply two binomial expressions, you get a quadratic trinomial. I'm just trying to say what our goal is and what the result is when I ask you to factor is to give me two binomials that make this work. Okay, so on the first one, these are problems that are just like on the exit ticket the last time. On the first one, we're going to draw a big X, and we're going to take the first coefficient, which is a 1, and that's a good thing because the simple one's first coefficient is 1. And the last coefficient was 12, and we're going to multiply those together. 1 times negative 12 is negative 12. And then the middle coefficient, in this case, is 1, because that's a 1, even though it's invisible in front of the x. All right, now we're looking for two numbers that multiply to negative 12 and add to 1. So how about 1 and 12? Well, negative 1 times 12 gives me negative 12, but 12 plus negative 1 is 11, not 1. Also, 1 times negative 12, yeah, we still get negative 11. All right, how about 2 and 6? Well, negative 2 and 6 gives me 4. 2 and negative 6 gives me negative 4, so I don't get 1. How about 3 and 4? Okay, now I think we're getting somewhere. Let's say 3 and 4 right here. And notice if I make the 3 negative, when I add negative 3 and 4 together, I get positive 1. But if I multiply negative 3 and 4, I get negative 12. So I think we found it. The magic x, when the first coefficient is 1, yields the result. So all we have to do now is write x and then this found number minus 3 and put parentheses around it. There's one binomial. The other binomial is x, and then we put this number in, plus 4. And we're done. Because if you multiply those two binomials together, you will get x squared plus x minus 12. And that's the goal. So this is the answer to factor that quadratic trinomial. Okay, here's a tougher one. Draw a big X. This is all based on using the big X, right? So 6 times negative 20, because we're taking the first coefficient, which is 6, and the last coefficient, which is negative 20, and we're multiplying it, we get negative 120. And the middle coefficient is 7, so we're looking for the numbers that we find to add to 7. All right, now we're going to find numbers that multiply to 120. So 120, let's see, 2 and 60. Well, once again, we aren't going to get anything close to 7 by subtracting 60 minus 2. So that's just not going to work. How about we're going to take 2 from 60 and give it to the 2 and that gives 4. And now we're looking at 30. 4 and 30, we're still not close enough. How about let's take 2 more from the 30 and call that 15 now and give it to the 4. Call it 8. Hey, I think we got something here because look at that. 15 minus 8 is 7. So that means, what if I were to say 8 and 15, and I know that when I multiply them together, I get 120 because that's how the factoring worked in just looking at 120. But one of them has to be negative in order to get negative 120. If I make negative 15, then negative 15 plus 8 is negative 7. So we didn't get it. But if we make negative 8, then 15 plus negative 8 does give me positive 7, and we're there. Okay, so we're going to use the area model this time, and the area model says take the first coefficient from the trinomial, so that's 6x squared, take the last term, negative 20, and then combine x with the two found numbers. So negative 8x, I'll go negative 8x down here, and I'll go positive 15x up here. Now we're just going to draw some blanks and fill them in with factors that we find of the numbers that are inside the area model. All right, what is the greatest common factor between 6x squared and 15x? Well, I see 3 is common in there, and I also see an x, so how about 3x? And then we just ask ourselves, what times 3x gives me x squared, 6x squared? what times 3x gives me 6x squared? Well, I see 3 times 2 is 6, so 2, and then I get another x because x times x now is x squared. So what times 2x gives me negative 8x? How about negative 4? Yep, that works. And then what times negative 4 gives me negative 20? Well, that gives me 5. And now we get to check and see, did we do everything right by multiplying 5 times 3x? And that gives me 15x, and we're looking good. All right, so this is saying that here is my binomials. 2x plus 5 times 3x minus 4. And we're done.